This conference will now be recorded.
All right. We are discussing the data modeling, right? And we have seen yesterday bunch of the scenarios. What happens if you write the deployment? What happens if you don't write the deployment? Then what is the meaning of persistent, type, property, dynamic? Okay. And what is the meaning of localization, no localization, LP table? All these things we have seen. And you remember yesterday, this is what we discussed. Okay, so let's take the user, okay, or customer. Let's take the customer, code equal to customer. So customer extends what? User. Customer extends user. Customer extends user, right? Customer extends user. Then user extends what? Let's see. Okay, so user extends right now nothing, or extends principal, because this is coming from the principal hierarchy. Okay, so the principal, you remember when we were discussing the functional sessions. Okay, so if you go on to see the principal, code equal to principal. Okay, so which extends generic item? Can you see this one, please? Hierarchy. Principal extends the generic item. This is one nice thing you need to understand. So principal extends a generic item. Now let's see the generic item. Let's see the generic item. Generic item extends what? Generic item extends localizable item. Generic item extends localizable item. Are you guys are paying attention?
Yes, sir.
Okay, good. Okay, so this extends localizable item. Now, if you see the localizable item extends extensible item. So this extends, that means this is having the parent called extensible item. Now, if you go on to see the extensible item, it is having the parent called item. It is having the parent called item. Next, if you go on to see the item, so this is the item here. Is it having anything? Is it having extends? So you can see item extends nothing. Okay, so item extends nothing. So that means item is the top in the hierarchy. Item is the top in the hierarchy, which is having. Can you see this one, please? Item is the top in the hierarchy, which is having creation time, creation date, all those things. Which is having creation time, creation date, all those things. You need to understand this one, please. Item is the top in the hierarchy, which is having creation time, creation time, modified time, PK. All these things are available in this. All these are available in this. So that's why whenever you create, please understand this. So in the item, you have creation time, modified time, okay, owner, PK and all. So that's why I think my server is started. Let me open the back office meantime. Okay, let me open the back office meantime. So that's why, so if you go and observe, okay, can you see this one, please? Let's go and see the customer, right? Let's go and see the customer. Code equal to customer. If you see the customer, am I having creation time, creation date, all those things? Am I having creation time, creation date? Okay, then modified time like that. Am I having creation time, modified time like that in the customer?
No, Chenna.
No. So then it is having the parent. Let's go to the user. Let's observe in the user. In the user, am I having creation time, modified time, all those things? No, we don't have it. So these are all coming from the parent called item. So therefore, item is having this creation time, modified time, owner, PK and all, and those are all inherited for your corresponding child types. Similarly, let's take the example of product, right? Let's take the example of code equal to product. Okay, you can see this is the product table design or product table code. Now here you have product code, product name, all these things, but you don't see anything called creation time, modified time and all. You don't see anything called creation time, modified time at all. But if you go to the database, you will see creation time, modified time, owner, PK numbers, all those things. So those are all coming because of this structure. Those are all coming because of this parent called item. Okay, so those are all coming because of this parent called item. Is that clear, everyone? So your product table, your user table, your order table, your cart table, all these are having creation time, modified time, all these things because of parent called item. Because parent called item. Now let's look at the back office ones. Let's look at the back office ones, then you will understand. Okay, so now look at here, please. If you go here, okay, so if you go to here, so you can go to any customer. Let's go to the customer first. So there are so many customers, right? If you open the customer and if you go to administration tab, so this is the customer is the type. In that, these are the records, and in that record, this is customer ID, customer name, all these are the columns. So if you go to the administrator, if you go to the administrator or administration, okay, if you go to the administration, then you can see, so you can see here, please. So there is a creation time, modified time, all those things, and a PK number. So please remember this PK number. So let's say I have a user table and I have some records, record 1, record 2 and all. Similarly, let's say I have an order table. Okay, so in the user table, let's say I have some records. Okay, user 1, user 2 like that. So let's say I have an order table. I have an order 1, order 2 like that. So PK number is the unique number for each record. Let's say for this PK number is 1, 2, 3. Then for this PK number is 2, 3, 4. Then for this PK number is okay 3, 4, 5. Now can I have PK number for this 1, 2, 3? Can I have what I am trying to say that PK number is unique in the system, not in the table. So now you can see PK number 1, 2, 3 is already here. Can I assign to one more, or can it be one more? Can it be for one more record? Can it be for one more record? Answer is no, that is not possible. So PK numbers are the internal numbers used by Hybris. PK numbers are the numbers generated and used by Hybris to recognize the records uniquely. To recognize the records uniquely. So that's why there is a PK number. Now, if you observe the output, can you see the output, please? Similarly, you can go to the product table. Similarly, you can go to the product table and open any one product. You will see creation time, modified time, all those things. You can open any one product. Okay, you can open any one product. You can open any one product. Now you can see, so there is a PK number, okay, then creation time, modified time, like that. Can you see this one, please? Can you see this one, please? You need to understand this here. Okay, if you go here, if you observe the creation time, okay, let me bring into the paint. Okay, so what is the difference you observe between creation time, modified time, PK number? What is the difference you observe between PK number, creation time, modified time? There is a small UI difference you can see. What is the UI difference you are able to see? What is the UI difference you are able to see? You don't see any UI difference.
PK is little bold.
It is little bold. Okay. Okay. Now let's come here, please. So this is the PK number. This is the creation time. This is the modified time. Can you observe this one, please? Okay. You need to observe this one. So let's take the example of creation time. So this is the creation time. Okay. Then if you see right equal to false is there. Right equal to false. Right equal to false means, okay, you will be able to put the column value one time, later you cannot modify. Okay, so that means when you are creating the record, that time you can put the value, later you cannot modify. So that's the meaning of right equal to false. That's the meaning of right equal to false. Now same thing you can observe for the, this is creation time, sorry, creation time, right? So here it is. Sorry, that arrow was wrong. So this is the creation time. Okay, so you can see creation time right equal to false. Right equal to false means during the record creation you can put the value. Once a record is created you cannot modify. So that's why you can see this section is grayed out. This section is grayed out. Are you able to observe? This section is grayed out. So you cannot do that. Okay, now let's observe the modified time. Can you see the modified time? So modified time, right equal to true is there. Right equal to true means you can set the value and you can also modify the value later. So that's why here you have an option to modify. Here you have an option to modify. So that's the meaning of create equal to true. Sorry, right equal to true, right equal to false. Right equal to true, right equal to false. So that means whenever you are creating the attribute, you can specify the modifiers. Whenever you are creating the attribute, you can specify the modifiers. These are called modifiers. So therefore, what is the conclusion? So the conclusion is whenever we create attribute means column. Okay, so then we can specify the modifiers. Modifiers, that means scope. So the first one is, okay, you can see right equal to true, right equal to false. What is the meaning of right equal to true? Right equal to true means later you can modify it. Right equal to false means later you cannot modify. During the record creation you need to put the value. Similarly, so there is a read equal to true. Read equal to true means okay, so read equal to true means you can retrieve the database value. So that means let's say this is the database and you want to read it. So that means there is a read equal to true. Okay, let me tell you in another words. In another word, a right equal to false. Right equals to false means what? Do I have a set method? Right equal to false means do I have a set method? No need. Okay, no set method. Right equal to true means what? You are going to write it, you are going to change it. So that's why set method will be there. So that's the meaning. So right equal to true means you can change the value later. So that means set method will be there. You can change the value later. So that means set method will be there. Right equal to false means so you cannot change the value later. So therefore there is no use of the set method. You cannot change it. There is no use of set method. Set method is to set the value. Get method is to get the value. Now read equal to true. Read equal to true means get method will be there or not. Okay, so get y method will be there, so that you are able to read the value from the database. So that you are able to read the value from database. Next. Sorry. Okay, next you can see there is a search equal to true. So what is the meaning of search equal to true? Okay, so let's say I am writing some queries. Okay, select star from. So let's say order table where, okay, select star from order table where order or order number, okay, or order code equal to 1, 2, 3. So that means here I am using the order code. Here I am using the order code means is it part of the search results or not? Here I am using the order code means is it part of the search results? Yes or no? I am filtering the data of this order code. Answer is yes. Similarly, you can see here. So let's say I am the product. Okay, I click on advanced. Then I want to search something. So let's say I want to search with EAN number. So select the EAN number, add it. Then EAN number greater than. So let's say contains. So I will use the contains 1, 2 or 2, 4. EAN number contains 2, 4. So right now 7,154 records are there. Now if I search it, okay, if I search it, now you can see I got the less records. So that means this particular attribute, this particular column, I am using part of the search. So if you want that kind of functionality, make search equal to true. If you want that kind of functionality, make search equal to true. If you want that kind of functionality, make search equal to true. Next, optional equal to true. Optional means what here? Optional equal to true. So that means you have to enter. Can I say optional equal to optional? Sorry, optional true means what? No need to enter, right? Optional true. Optional true means no need to enter. So that means when you are creating the record, optional true. Optional true, can I say mandatory false? Optional true means mandatory false. Can I say like that?
Yes, sir.
Yes. Okay. So therefore, optional true means when you are creating the record, if you are not entering, that's okay. It will allow. So that's the meaning of optional equal to true. Then initial equal to true. Initial equal to true means by default you need to have some value here. Initial value will be there. Initial equal to true means some value will be there here. So that means, let's say when you are creating a record, so let's say insert into, so what is this product table values. So let's say product code and the product name, and remaining you are not entering. Even though you are not entering, it will allow. So because optional true. And initial value can be what, 0 or something like that. So you remember initial value means default value. Do you remember there are some default values, right? core-advanced-deployment type. So you can see, so if you are not entering for float, what is the default value? If you are not entering for float column, float attribute, what is the default value? 0. So like this, you can set the initial value if you want. Like this, we can specify the modifiers for the attribute or database column. Like this, we can specify the modifiers or attributes for the database column. That's it. Okay, that's it. So similarly, you can see, and we have understand persistent. So I told you these are the old ways. Persistent type equal to CMP. All these are deprecated. Now you have only two values, dynamic and one more is what? Persistence. Persistent means this will create in the database. Dynamic means that will not create in the database. That is only used for calculation purpose. That is only used for calculation purpose. This is what we understand, and this is what the hierarchy also you need to remember. Okay, next. Now we want to do the data modeling, right? Okay, so data modeling is given where in asterisk hyphen items.xml, sorry, in asterisk hyphen items.xml, asterisk hyphen items.xml. Example, so you have a core hyphen items.xml, you have a cms2 hyphen items.xml, like that, so on, so on, so. Now the question is, if we want to do the data modeling, if we want to do the data modeling, then where can we do? If we want to do the data modeling, then where can we do? You remember during the installation, we got 7 extensions, right? During the installation, we got 7 extensions. In that there is a core extension. In that there is a core extension. In that there is a resources. There is a item.xml file. This is where we will do the data modeling. This is where we do the data modeling. So that means that tomorrow you want to create a table, you want to create a column, all those things. Which is the preferred one? You want to create a table, you want to create a column, you want to modify a column and all. So where do we do? Asterisk core extension. Okay, so therefore the answer is asterisk core hyphen items.xml, where here asterisk means the name. What is the name we have given? ChennaReddyTraining we have given. So this is where we do the data modeling. This is where we do the data modeling. That's it. Next, one more thing is that, let's say, okay, so let's say you are writing a C program here. Let's say you are writing a C program. Are you following some syntax? Main. Let's say you are writing some C program. Main, then open brace, printf, let's say Chenna, and close brace. Like that, you are following some syntax. Similarly, let's say you are creating a HTML. Are you following some syntax? HTML, okay, head, okay, then you do something, then end head, like that. Are you following some syntax? Body, okay, then you do something, then end body, then end HTML. Are you doing like this or not?
Yes, sir.
Yes. Similarly, to do data modeling, we need to follow some syntax. So similarly, so to do the data modeling, okay, we need to do the data modeling. We need 6 tags here. We need 6 tags. Those are nothing but ACEMRI. Those are nothing but ACEMRI. So these are also called as type system. Okay, so however you have some syntax in the C language, however you have some syntax in the HTML, and so on, so on. So to do the data modeling, we follow some syntax. Okay, we follow some syntax. That's nothing but ACMRI. That is nothing but the type system. A means atomic. Okay, C means collection. E means enum. M means map. R means relation. I means item type. So if we understand these 6, that's it here. You are good to do the data modeling. If you understand these 6, that's it. You are good to the data modeling. And please remember this, as I said, to do the data modeling, to do the type system, we need 6 tags. 6 tags. Those 6 tags are nothing but ACMRI, and this order is important. Okay, this order is important. So what does that mean? Okay, what does that mean? Let's say in your project, can you please pay attention? So let's say in your project, there are no enums. If you don't have the enums, then don't write it. Okay, so let's say in your project, can you see this one please? ACEMRI. Okay, ACEMRI. So let's say in your project you don't have any enums, then don't write it. That is correct. But don't change the order. If you change the order, then you get errors. So let's say enums you are keeping at the end, then this is wrong. So therefore, this order you have to follow. This order you have to follow. You cannot just put the order however you want. Now you can ask a question. I am telling this order is required, right? You can ask one question. What is the question? Why to follow this order? Okay, so the question is why to follow this order, or why this order is important? Why we need to follow this order? Anyone here? Okay, why we need to follow this order? Because we are doing the data modeling where? We are doing the data modeling in the *items.xml. Okay, items.xml. So that means in a simple word, we are doing in the XML file. So every XML follows the XSD syntax. So that means whenever you do some changes here, can you see this one please? Can you see this one please? Whenever you do some changes here, these changes read, understand, scan, whatever terminology you want, you can use it. This XML read, scan, and understand based on the XSD syntax. Based on the XSD syntax. So therefore, we are doing the data modeling in the *item.xml file. This item, so in a simple word XML file, every XML will have XSD, follows the XSD syntax. This XSD is given by SAP Commerce. Hence, we need to follow. Is that clear, everyone? Is that clear, everyone?
Yeah.
Am I disconnected? Hence, we need to follow that syntax. So therefore, to do data modeling, we need 6 tags. Those are nothing but ACEMRI. That order is important. If you don't have something, you can leave it, but don't change the order. Why that order is important? Because we are doing the data modeling in the XML file. So every XML file will be understand, will be read, will be scan, whatever terminology you want, you can use it. But finally, that is understand based on the XSD syntax. These XSDs are given by the SAP Commerce. That's why we are following that order. Then only your XML changes will be recognized and compiled and read and scan and parse and so on, so on. So that's it. Okay. So that's about this one. Then you can remember this order here, ACEMRI, like that. So A means atomic, C means collection, E means enum, M means map, R means relation, and I means item type. So if you understand these 6, that's it here. You are good to write the data modeling. That's it, simple, straightforward. Now let's understand what is the meaning of atomic types. Let's understand what is the meaning of atomic types. Okay, so let's say as per the mathematics, what is the different data we have? As per the mathematics, what is the different data we have? So please remember this here. These are all we are using to create the table, to create the column, to store the data. That is the ultimate goal. To create the table, to create the column, to create the data. That's the ultimate goal of the data modeling. So therefore, now come to the atomics. So generally, what kind of data we have? We have the data something like a 20, minus 20, okay, 40, minus 40, like that, right? Okay, if you want to store this kind of data in the database, if you want to store this kind of data in the database, then you can use integer or long, like that. Integer or long, like that. So integer will allow less number range, long will allow more number range. So as per the C language, so let's go to the C language. As per the C language, if I write integer, so let's say integer x, Then what is the range of values I can store? What is the range of values I can store in X? What is the range of values we can store here? So 32,767 to minus 32,768. 768. These are the numbers we can store. Now, if I want to store more than, so let's say if I want to store, or I want to store 40K, is that possible? So I want to store 40K. If you want to store 40K, then you need to go with the long. Go with the long. Long will allow to store 10-digit data. Long will allow to store 10-digit data. So that's why I'm saying, so we can have data like this, 20, minus 20, 25, 45, minus 45, like that. If you want to store this data, so these types you can use. Okay, good. Next, come here. So let's say I want to store 20.5 minus 20.5, like that. If you want to store this kind of data, you can use float or double. Okay, then I want to store ABC. Okay, so I want to store Chenna, like that. If you want to store this kind of data, you can use string. What else we have here? We have true false values. True false, like that. True false values. True false, like that. If you want to store this kind of data, then you can use Boolean. Then you can use Boolean. So therefore, these are all called atomic types. So that means, let's say, simple example to understand the simplest way. I am creating a employee table. Okay, so I have a employee ID. So can I say employee ID is a long? Can I say employee ID is a long? Because it's a, can I have employee ID 20.5? Can I have employee ID 20.5?
No.
No,
No. So that's why you need to mention this employee ID of type long. Okay, employee ID of type long. Then next, employee name. So can I say employee name is a long? Employee name is a long. Long means digits. No. So you have to go with the string. Okay, next, employee salary. Tell me what can I go? Employee salary. Tell me what can I go? Can I go with integer, double, or
No.
string, or Boolean? Employee
No.
salary.
Double.
Okay, you can go with a double, because double or float, whatever it is. So generally we don't need that many digits, right? We go with the 2 digits after the decimal. That's why you can go with the float. You can go with the float. Okay, because the reason is some people get okay, 1,45,080 paise, like that. So that means float is fine. Then let's say we also have one more thing called so let's say employee join date, date of join. So here I need to go with what? Type date. I need to go with a type called date. Next, let's say gender, male or female. Then here no, we can go with the, okay, so let's say active. So tell me active employee. Sorry,
Boolean.
Santosh, need to go on mute. Okay, thank you. So active employee, that means whenever you are creating a employee, you will mention is he active or inactive. So active means type equal to Boolean. Type equal to Boolean. Like this, you need to specify the column types. So those are called primitive types. Now, can I say this conclusion? Primitive types. Okay, so can I say this sentence? You can tell me. Okay, primitive types tells what kind of data we are going to store in database column. Is that sentence is correct now? Primitive type tells what kind of data we are going to store in the database column. Is that correct?
Yes, Chenna.
Yes. Yes. You can see that is what I explained till now. So primitive type tells what kind of data. So are you going to put the digits? Are you going to put the characters? Are you going to put the numbers with the decimals? Are you going to put the date? Are you going to put the true false values? So therefore, obviously primitive types tells what kind of data we are going to store in the database column. What kind of data we are going to store in the database column. Then tell me, is there anything else you can input it? Is there anything else you can input it? Do you have anything else to input here?
Image.
Image. Okay, image is fine. Okay, good. So for that you have a blob, binary lob. Okay, very good. Image is also correct. Like this, we have primitive types. So with the help of the primitive types, you are going to tell what kind of data you are going to store in the database column. You are going to tell what kind of data you are going to store in the database column. Okay, now to understand these primitive types, let's do one small exercise here. So because this example is important, let me go to the notepad. Okay, let's say I am writing a C program. Okay, float x equal to, let's say 3.4. Float x equal to 3.4. Then I am writing if x double equal to 3.4. Then I am saying printf Chenna else printf triple RS. So this is what the program I am writing in the C language. This is the program I am writing in the C language. Same program, how do I write in the Java? Same program, how do I write in the Java? So Java program will have a class, public class ABC. Then in the Java, instead of main, what do you have? Public static, okay, void main we have. And here you need to pass the arguments. Let's say string args. Okay, float is fine, this is fine. Then in the Java, what do you have? System.out.println. Okay, system.out.println we have in the Java. So this is what the program I am writing in the C language and the Java. Tell me what is the output in the C language, what is the output in the Java? Tell me what is the output in C language, what is the output in Java? That's it. Are you guys are there?
Yes, Chenna.
What is the output in C language? So this is the C language code. This is the Java code. I want to give one nice conclusion here. That's why I'm covering this as part of the primitive types. I want to give one nice conclusion. That's why I'm covering as part of the primitive types. Yeah, go ahead.
Chenna.
So Chenna. What about in Java? There also Chenna.
Yes.
Okay, good. Okay. Now let's see this one, please. So this is the program we have written here. This is the program we have written here. Now let's understand. So please remember this. The conclusion what I am trying to say that. Okay. So here x is what? Float. Here x is what? Float. In the C language, float means 4 bytes, right? 4 bytes. 4 bytes memory. So if you don't know, if you are a functional person, okay, if you don't know what is this memory and all, just remember 4-liter box. That's it, 4-liter box. That's it. So that means if I say float x, x will take how much memory? X will take 4 bytes memory. Okay. Now can you see this one? This x is 4 bytes, but right side is what? 3.4. Whenever you mention 3.4, by default it is double, which is 8 bytes. So that means you are comparing left side 4 bytes of data with right side 8 bytes of data. then some fraction of digits difference will be there. So let's say left side is 3.4, right side may be 3.3999999 something, some fraction of digits will be there. So that's why this will not match. Hence, you will get the output called the triple RS. You will get the output called the triple RS. That's it. Now come to Java. So in the Java, the moment you write like this, it will give compile time. It will give error. It will give error. So what is the error it will give? It will tell that, hey, left side is float, right side is a double. I am not going to entertain this kind of operations. I am not going to entertain these kind of things. Please correct it. Like that it will tell. So that's why Java is called strictly typed programming language. That's why Java is called strictly typed. Okay, type programming language. Okay, strictly type programming language. That means it is very strict with the types. Left side, right side should match, then only it will continue. Otherwise, it will not continue. It will give the error. Now, let's say you want to tell to system, hey, I know left side is okay, I know, and I want to continue this. If you want to continue this, then you need to tell to the system, don't worry. Okay, so you need to tell to them, okay, 3.4 F. So by mentioning F here, then left side is float, right side is float, then it will continue and give some results. So these are the 3 points you need to remember. So therefore, the point what I want to conclude here is that in the programming languages, whenever you specify number without decimal, default it is integer. Whenever you specify number with decimal, by default it is
Double.
okay. So therefore, in programming languages, this is the conclusion. In programming languages, if you specify number without decimal, then those are integers by default. Okay, if you specify number with decimal, then double by default. This is same everywhere here. So this is a small difference, but it is same in Java, .NET, SAP, everywhere. But we have to remember this nice conclusion as we are discussing about the primitive types. That's it. If you have any questions till now, you can go ahead and ask.
This conference will now be recorded.
Okay, all right. That is about the primitive types. So therefore, we will use the primitive types to tell what kind of data we want to store in the database column. That's about the primitive types. So therefore, we have AC, MRI. Out of that, we understand the what is A, atomic. So that's why you can see here, whenever you are creating a database column, you can go to the product table once and see it quickly. Okay, so whenever you are creating the database column, you can see here, whenever you are creating the database column, you are specifying the type. You are specifying the type. You are specifying the type. And so on, so on, so. Good. Next, that is about atomic. The second one is collection. Okay, second one is collection type. So what is the meaning of collection type? Let's understand. Second one is collection type. What is the meaning of collection type? Let's understand. To understand the collection type, what I will do is that I will take a small diagram. This is the excellent diagram here. This will give lots of meaning. Let's take this diagram and understand the collections. Let's take this diagram and understand the collection. Can you guys hear me?
Yes, Chenna.
Hello, can you guys hear me?
Yes, Chenna.
Okay, good. Okay, good. So now can you see this one, please? This is the collection I want to explain. So first I will delete something. Please pay attention. There is a nice knowledge here. Okay. Now look at here, please. Can you see this one, please? We are discussing the collection type. That's good. So now we have to assume that we have two tables: user table, order table. Now there are four users: user 1, user 2, user 3, and user 4. And the users place the orders. So let's say user 1 is placed this order. Okay. Next, user 1 placed this order, and user 1 also placed this order. Next, user 2. User 2 did not place any orders. Next, user 3, he placed this order. User 4, he placed this order, this order. Like that, user table is there, order table is there. Then what's the relation between user table and order table? Then what is the relation between user table and order table?
1:many.
Relation 1
User
to
ID.
many. One user can place the n number of orders. That's good. Now the question here is, I want to find out how many orders each user is placed. I want to find out how many orders each user is placed. That's the question. Now tell me, how do you write the query? I want to find out, let's say user 1 placed 3 orders, user 2 0 orders, user 3 1 order, user 4 2 orders, right? I want to find out how many orders each user is placed. That is the question. Now how do I do that?
We will do group by employee ID.
Tell me, what is it? Yeah, there is a lot of background noise, Santosh.
Select.
Maybe go on mute.
We can do select count of order ID from the orders table, group by user ID.
Okay, Santosh, there is a lot of background noise from your side. Don't mute it. Don't unmute, please. Okay, you can be on mute. Thanks for answering, but there is a lot of background noise. Okay, so right. Now let's come back here, please. You are right. Okay, so then we can write the query like this. See this query, please. Select user ID, and for each user ID, I want to find the number of orders, right? So therefore, count of order ID. Select user ID, count of order ID from user table, order table, where this user ID should match with the order table user ID. This user ID should match with the order table user ID. And we want to have the final count. That's why group by order group by user ID. Group by order user ID. Like this we are writing. So therefore, with this query, this is the results. With this query, this is the results. Now you can see user 1 3 orders, user 2 1, user 2 0 order, user 3 1 order, user 4 2 orders. Like that we get it. Now this will work no problem. But what is the challenge here? The challenge is, let's say first for user 1, I want to find out how many orders. So that's why I'm scanning this entire table. Now for user 2, I want to find out how many orders. Then I'm scanning this entire table. Then for user 3, I want to find how many orders. Then I'm going through the entire table and finding. For user 4, I want to find how many orders. Then I'm going through the entire table and finding how many orders, and so on, so on. So that means for each record, you are going through the table and finding how many records this user is placed, how many records this user is placed, how many records this user is placed. Like this, we are scanning the entire table. That means it's kind of a performance challenge. It's kind of a performance challenge. Then what to do? There are so many ways here. There are so many ways, but if you ask me, then this is one of the solution. This is one of the solution. Now this is the user, right? Whenever user place the order, let's say this user places this order, I will take that order ID and keep in the user table. Whenever this user place the order, I will take that order ID and keep in the user table. Whenever user place the order, I will take that order ID and keep in the user table. So that means in the user table, I am going to create one more column. That means in the user table, I am going to create one more column. That means in the user table, I am going to create one more column and maintain all the order numbers here. So that means I will perform two operations. Okay, go ahead and update the create the order in the order table, then take the order number and update in the user table. Update in the user table. Now you can see here, is this the normal data? No, this is not the normal data. So to store this kind of data, then we can go this column of type collection. To store this kind of data, then make this column of type collection. To store this kind of data, make this column of type collection. Then collection is two type. Collection of type list, collection of type set. Then when can I make this column collection of type list? When can I make this column collection of type set? Okay. Next, if you want to allow duplicate values, go with the collection of type list. If you don't want to allow duplicate values, then make this column of type collection set. Now in this scenario, you tell me, shall I go with a collection of type list or collection of type set? You can tell me now, because I told you, if you want to duplicate values, go with a collection of type list. If you don't want to duplicate values, go with a collection of type set. Now for the current scenario, do I need to go with a collection of type list or collection of type set?
Set.
Why set? Because order numbers are unique and there is no duplication. Order numbers are unique, there is no duplication. So that's why define this column collection of type set, and so on, so on, so on. Now I want to find out this user how many orders placed. If I want to find out this user how many orders placed, I can simply read this collection. Okay, collection will have the methods, right? I can use the method and find out how many orders. Collection.empty, collection.count, like that. You have a methods in the collection. So I can use that methods and find out. I'm not iterating the tables to find out how many records are placed. So this is the excellent advantage with the collection. Now you should not forget what is the meaning of collection lifelong. This meaning is same wherever you go. Whether you go to Java, whether you go to some other place, whether you come to SAP Commerce, collection means it will allow set up the values. And this is the one of the nice example to visualize the big advantage with the collection. Is that clear? So therefore, if you want to store this kind of data in the database column, then make this column of type collection. Then collection list is there, collection set is there. When can I go with the list? If you want to duplicate values here, go with the list. If you don't want duplicate values, then go with the set. That's it. Is that clear?
Yes, Chenna.
Okay. Now if you see one more thing here, so collection of, okay, now it is a collection, right? Now, so this user placed these many orders. Is it like a one-to-many relation? Collection is like a one-to-many relation?
Question.
Yes. Then the important question is, so collection is like a one-to-many relation. Is like a one-to-many relation. Then question is when to use collection and when to use one-to-many relation. When to use collection, when to use one-to-many relation. Okay, simple here, I'm telling in the simplest way. If you have limited data, or if you have, if you know what is the data and size, okay, if you know the approximate data size. I will put the code called approximate. If you know the approximate data size, then go with the collection. Okay, if you don't know what is the data, how much of data size, okay, if you don't know the approximate data size, then go with the relation. What the advantage? Let's say I know that, okay, there are 20,000 values, there are 50,000 values, then go with the collection. If I don't know how many values, is it a 20,000, 1 lakh, 1 million, then go with the relation. Okay, in a simple word, if you don't know the size of the data, go with the relation. If you know the size of the data, or approximate at least, I'm not telling exact here, approximate, then go with the collection. Then why to go with the collection if I know the data size? The reason is retrieval of the data is very fast. Retrieval of the data is very fast if it is a collection. Retrieval of the data is very fast if it is a collection. Then this is the advantage. Then what is the advantage with the relation? So this is the advantage with the collection. What is the advantage with the relation? So the advantage of the relation is, what is the advantage? So we can have, okay, we can have more data. That's it. So this is the nice example you need to remember, because most of the interviewers are asking that question. So that's why I can see here. So the advantage of the collection is retrieval is very fast. The advantage of the relation is, okay, you can have n number of data. Disadvantage is what? Size. Or data size. Advantage is what? Data size. Or disadvantage in the relation is what? Retrieval is little slow. So therefore, when to use the collection, when to use the relation. Just now I told, this is what you need to remember about the collection and the relation. Is that clear, everyone?
Yes, sir. So even if data size is like large, if it doesn't grow, we can go with collection, is it?
Correct. So that's what I use the word called approximate data. So if you are thinking that you know the approximate data, then go with the collection. Why to go with the collection? Retrieval is very fast. If you don't know what is the size of the data, and it may be 1 million, 10 million and all, go with relation. Then the advantage is it can allow more data. Then disadvantage is it is okay that, okay, it is like a performance. Retrieval is little slow, which is okay because you are taking some advantage, then you will lose something else. That's it. That is about the collection type. Now if you have any question with the collection type, you can ask me, else we'll go to the next one. Are we good?
Yes, sir.
Okay, good. So now let's come back here. We understand what the meaning of atomic. We understand what the meaning of collection. Next one is enum. Next one is enum. So enum type. So when can I make a column as enum? Okay. So when can we make a column as collection? Just now I told. When can we make column as primitive? We have discussed. Now when can we make a column as enum? So let's take a scenario here. So I have a employee table. Okay, I have a employee table. Okay, please understand this. I have a employee table. Then there is a employee ID, employee name, and let's say there is a gender. And the gender is a string right now. So 101. So let's say Chenna. Okay, gender is, let's say, male. 102. Let's say triple RS. So gender is, let's say, male. 103. These are the nice simplest examples here to understand big concept. So let's say 103. So let's say Santosh. Okay, or let's say Kiran. Okay, so male, and 104, let's say Lakshmi. Okay, so let's say female. Okay, like this I am writing. See, okay, please understand this. This is the table, and here gender I am making it as string. Then I am able to store this is the male, this is the male, this is the male, this is the female. I am able to put the data. So we are able to accommodate the data, put the data. But do you see any challenge here? Do you see any challenge here?
Yeah, even though male and female only two values, we have different case sensitive values.
You can see here it is all one letter is cap letter, all small letters, all capital letters. Okay, something is, so that means there is a possibility that, what is the challenge? There is possibility that you can have small letters, capital letters, that combinations, okay, and so on, so. That means the data is not looking good. Data is not looking good. So therefore, if you have fixed values for your database column, then go with enum. If you have fixed values for your database column, then go with enum. Okay, then go with enum. So when you go with enum, you only have option called select. Let's say example, can you see this one please? Product status. Product status is fixed values or not? Product status, fixed values or not? Fixed values, right? So therefore you can make it as enum so that you can only select it. You can only select it. You cannot type here. Okay, you cannot type. You can see when you see it is gone. Are you guys getting me? So therefore, if you know your database column is having fixed values, if you know your database column is having fixed values, if you know your database column is having fixed values, then go with enum. In this case, you can define enum. Okay, some name you can give it. So, and you can define it as a male and female. Then in the drop down, you only get that options. Can you see this one, please? In the drop down, you only get that options, and you will not see anything else. You will only get that options. You will not see anything else. That means you can select it, and you cannot do any mistakes like capital letters, small letters, combinations and all. So this way you can make sure typo mistakes. This way you can make sure typo mistakes. Is that clear? What the biggest advantage with the enum? So when can you make a column of type enum? So if you have fixed values for your database column, if you have fixed values for your database column, make it as a enum. Example, so I'm just giving a order table. In the order table, so let's say order number and card type. So tell me, card type is enum or not? Card type, shall I go with enum?
Enum, yes.
Yes, fixed values, right? What is the card type? Visa card, MasterCard, like that. Then order status. Order status means what? Approved, delivered, okay, shipping and all. Fixed values. So you can make all these as enums. You can make all these as enums. Is that clear?
Yes.
So that's why even if you go here, you can see, so click on the design here, click on the design and click on the enums, click on source, it will take you to that place. Okay, you can see there are a bunch of the examples. So you can see credit card type, Amex, Visa and all. Okay, order status, okay, payment status, fixed values, fixed values. Okay, so you can see gender, male and female. Like that we have fixed values, so on, so on, so on. Like that we have fixed values, so on, so on, so. That's it. Okay, so in C language also we have enums, right? Is it the same purpose in the C language? In the C language also we have enums. Is it the same purpose? Yes, there also it is the same purpose, but it's not a column there. So it's a if you have fixed values, Then in C language also we use enums with the help of hash define. With the help of hash define. Here also it's the same. So therefore the final conclusion is, if you want to keep database columns, or if you know that your database column values are fixed, then go with the enums. Okay, now let's say I have so let's say I am creating an employee table, and employee ID, employee name, month of join. Now can I go with this as enum? Month of join, can I go with enum?
Yes,
Month of the join, can I go with enum or not?
Yes, Chenna.
Yes,
Yes,
because we only have January month, February month and all. January month, February month, March, April, May, June, July, August, September, October, November, December. Like that we have only 12 possible values. So therefore, if you have fixed values like that, then go with the enums. Now here there is one thing, just observe here please. 31, 30, 31, 30, 31, 31, 30, 31, 30, 31. So now do you remember here this logic? So this is having 28 or 29 because of leap year. And it's like a 31, 30, 31, 30, 31, 30. Then why August and July are having continuous 31? Why August and you can see remaining are 31, 30, 31, 30. Why August and July are having July and August are having continuous 31s? Are you guys are there?
Yes.
Okay, so the answer is the calendar, whatever we are using, was introduced or proposed or invented, whatever terminology you want, you can use it. Okay, so that was given by Augustus and Julius scientists. With that, with their names, we have August and July. So they are both equal. That's why 31, 31. Okay, that's it. Okay, you can Google it. You will find the answer if you want. Okay, and similarly, you can also Google it. One more thing here. In 1 year, in 1 month, there are only 14 days. Find out which year, which month, 14 days are there, and find out why reason. Okay.
Okay, Chenna.
Okay, good. Now let's come back here, please. So that's about the enum. So therefore, simple. If you want to store or if you have a fixed values for your database column, make it as a enum. That's about the enum. Now let's come back here. Let's come back here. Atomic we completed, collection we completed, enum we completed, then map. Map is not that important here. We'll spend some time, and there is one interview question on that. We'll understand that interview question and we'll move on. Map. So map is used to store key value pairs. Key value pairs. Okay, so map is used to store key value pairs, and the keys are unique. Okay, values can be duplicate. Keys are unique and values can be duplicate. Now let's see example. So let's say I'm creating a map, m equal to new hash map, whatever you call it as. Okay. Then I am putting some values in the map. M dot put, let's say key 1 equal to or key 1. So I am putting Chenna. Okay. So m dot put. So let's say key 2. So I am putting triple RS. Okay. M dot 3. Or so m dot put. So let's say key 3. I am putting let's say SAP Commerce. Okay. Then m dot put. Okay. Key 2. So let's say I'm putting Spartacus. Is this correct here? So I said just now keys. Okay, in the map we can store the key value pairs. Keys are unique. Values can be duplicate. But you can see there is a key here, there is a key here. Is this correct? Is this correct or wrong?
Yes, correct. The second one will replace.
Okay.
The second key will replace.
Correct. So please remember this here. Is this correct? Yes, this is correct. No problem. Then when you print key 2, when you access the key 2, what you get Spartacus. So that means whenever you do like this, okay, so key 2 already exists with the triple RS, right? That triple RS will be replaced with Spartacus. That triple RS will be replaced with Spartacus. That's why when you access the key 2, when you read the key 2, you will get the Spartacus. That means there is no triple RS. So this is not the error here. This is the point you need to remember. This is not the error. So this is correct only. The key which was exist is having some value. That value will be replaced with a new value. That's why when you access that key, when you read that key, when you use that key, then you will get the latest value, which is nothing but the Spartacus. And in this situation, this method returns true here. In this situation, this method returns true. Okay, so this is the one more point you need to remember. This method returns true. In this situation, this method returns true, but in this situation, this method returns false. So by returning false, what do you understand? Okay, this method returns false. By returning the false, by looking at the false, what do you understand? This particular key already exists. That's why when you try to attend some interviews, like a Google and all, there is one famous question here. The question is, let's say I'm trying to put lots of key values in the map. I'm trying to put lots of key values in the map, and I want to count how many duplicates are there. How many duplicates are there? Then how do you find out? So you can simply write the loop. And if at all method is returning false, you can increase the count. If at all method is returning the false, then you can increase the count. Final count is nothing but those many duplicate keys were there and you replace those. Is that clear?
Yes, Chenna.
Yes, Chenna.
So like this, we can use the maps here. Maps are used to store the key value pairs. And the point you need to remember is, if at all you are using the key one more time, then the key which was exists already with some value will be replaced with the new value, and this put method returns the false. These are the 2 points you need to remember for the maps. That's it. Now the next one is relation. Relation is again important. Okay, next one is relation. Relation is again important. Okay, so relation means what? So we already discussed the relation many times. So whenever you have, because we are discussing the data modeling means tables. Whenever you have the tables, obviously relation is important. Whenever you have the tables, obviously relation is important. Okay, so as per the mathematics, how many relations are there? So we have one-to-one relation, one-to-many relation, many-to-one relation, and a many-to-many relation. This is as per the mathematics. Then as per the programming languages, we have only 3: one-to-one, okay, one-to-many, or many-to-one, and the final one, many-to-many. So please remember this, in the programming languages, these two are same. One-to-many, many-to-one is same. One-to-many, many-to-one is same in the programming languages. So therefore, as per the mathematics, we studied 4, but programming language, especially in the commerce and all, we have 3. So therefore, now we have a user table. So let's say we have a user table. We have the order table. What is the relation? One-to-many, right? So we have a user table. We have a cart table. What is the relation? One-to-many. Like this, we can define the relation. Like this, we can define the relation. So please understand this. Like this, we can define the relation. So to define the relation, so we have source and we have target. Source is nothing but left side type or table. Okay, left side type or table, and the target is nothing but right side type or table. And this relation we can define with a cardinality. We can define with a cardinality. That's it. This relation we can define with a cardinality. Let's see some examples. You can go to this code and look for the user to cart. So can you see this one, please? This is what I mentioned. You can see relation name, user to cart, and generate equal to true. All these things you will understand now. Okay, now you can see there is a source element and a target element. There is a source or source element. There is a target or target element. Source is what? User. Target is what? Cart. User to cart, I am defining the relation. And that relation is nothing we can define with a cardinality. You can see cardinality is 1 here, cardinality is many here. So this is how you can define the relation between two types or two tables with the help of cardinality, with the help of source element and target element. That's it. Now you can see there are so many relations. User to order. So user is left side, that is nothing but the source element. Order is right side, which is nothing but the target element, and the cardinality you can see 1 to many. Like this you can define the relations. Let me ask a question. User to, okay, so we have a user and we have contact info. Tell me user to contact info, what is the relation? User to contact info, what is the relation?
1 to many.
1 to many, huh? Okay, so the answer is 1 to many. The reason is what? Whenever you join the company, you will say, oh, take my temporary phone number, take my permanent phone number, take my uncle phone number, take my hostel address, take my hometown address. Like that, you give multiple contact info. So that's why user to contact info is 1 to many. Like this, you can define the relation. Then finally, we have nice questions here. To have one-to-one relation, how many minimum tables required? This is the question number 1. Then to have one-to-many relation, how many minimum tables required? Next, to have many-to-many relation, how many minimum tables required? This is the question. Okay, for one-to-one relation, how many minimum tables? Minimum here. Tables required. For one to many relation, how many minimum tables required? For many to many, how many minimum tables required?
2, 3, 4.
2, 3, 4.
2. All 2.
2.
All two. Okay. Okay. So first one is what? 1 to 1. 1 to 1 means self here. For self, one table is sufficient. Okay. 1 to many. 1 to many means minimum 2 tables. And many to many means minimum 3 tables are required. The reason is, okay, you have a source element, you have a target element, and whenever there is a many to many relation, that relation you need to keep in one more table. Let me show you an example. Okay, let me show you one example. So many to many, right? Many to many. Okay, yeah, this one. Can you see this one, please? So there is a relation which we are creating between, okay, principal and principal group. principal and principal group, and cardinality is what? Can you see the cardinality? Many, cardinality many. So whenever you are creating many to many relation, this relation you need to keep in a separate table. That's why you are writing the deployment here. So deployment is nothing but the table again. Deployment is nothing but the table again. So therefore, total 3 are required for many to many relation. That's it. That's about the relation. Now, so far, if you have any questions, go ahead and ask. Any questions so far?
When to use deployment table for relation?
When you have many to many relation, that's what I am telling.
Okay, for one to many we don't need, right?
Yes, correct. Only for many to many, we need that deployment.
Okay.
That means many to many relation, we will keep in the separate table. That's why we are defining the deployment here. Okay, all right. If no questions, the next important and heart of the data modeling is item type. Okay, so the next important and heart of the data modeling is item type. So the last one. So that's why it is called the heart of the data modeling or heart of the type system. So because everything will begin from here only. Everything will start from here only. Okay, so everything will start from here only. So example, just now we have seen, we already studied something, right? So you can see product table, order table, like that. So for now we will understand this here. We'll see how to create our own tomorrow. So tomorrow we have the session. Look at here, please. So you have item type product. Okay, you have item type product. So we start with this and do so many things. That's why I'm telling it is the heart of the data modeling. Okay, we start with it and do everything. That's why we are telling this is the heart of the data modeling. Okay, now let's understand. So this Jalo are deprecated. We don't need to spend the time. Jalos are deprecated. We don't need to spend the time. So now let's understand. Okay, so let's understand here. So there are 3 things are defined or 4 things are defined here. Let's understand this. Okay, so product. Okay, let's come here, please. Can you see this one? Can you see this one? Okay, so this is what item type name, and this is nothing but the parent. So that means product extends the generic item. Product extends the generic item. Then we have something called auto create equal to true, generate equal to true. What does it mean? Let's understand. Auto create equal to true, generate equal to true. What does that mean? Let's understand. Auto create equal to true means, okay, so auto create equal to true means this item type, okay, this item type or this table will be created in database. This item type will be created in the database. If you mention false, the meaning is you are telling to, if you mention false, you are telling to SAP Commerce that this type already exists and continue to update it, not create it. Is that clear? Auto create equal to true means if you say true, you are telling to SAP Commerce this item type does not exist, go ahead and create. If you mention false, then you are telling to SAP Commerce this item type already exists, continue to update it, continue to modify it. That's what the meaning of auto create equal to true. That means, let's say when I am creating a table first time, that means when I am creating a table or a type first time, so do I need to make it as create equal to true first time?
Yes.
Yes. So later I am adding the auto create equal to true. Okay, later I am adding some attributes. Okay, I am modifying some columns. and so on, so on. So then I need to make it as false. That's why if you go and observe, can you observe this one, please? That's why if you go and observe, okay. So I'm searching this. Can you please observe this clearly? I'm searching this in the item.xml file. When I search, how many times it appears? You can see it is appearing in the 15 places. Out of the 15 places, how many places it should have create equal to true?
1.
Out of the 15 places, how many places it should have create equal to true? Only one place, right? Let's see. So you can see here it is there, create equal to false. That's correct. Because we are trying to add it or update it or modify it. Create equal to false. You can see all the places it is having create equal to false. Only one place it is having the create equal to true. So that means that time or that is the main one, and remaining all are like a extending or adding, modifying like that, and so on, so on. So here you have the create equal to true. So that is the meaning of auto create equal to true if you mention at the item type level. Next, similarly, you have generate equal to true. Generate equal to, see, this is for the database side. Auto create equal to true is the database side. Generate is for the models file. Models file. So now, okay, generate equal to true means you are telling to SAP Commerce generate the models. Generate the models. And if you say false, then model already exists, append it. So now let's say if I go here, you can see, so remaining places model equal to false, 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 everywhere it is false. So therefore, one is related to the database, telling to database whether you are creating or updating it. Another one is for the models. This is what the attributes we need to specify. These are the attributes we need to specify whenever you are creating the item type. And Jalo is replicated, you don't need to spend the time on the Jalo. That's it. Similarly, can you see this one, please? I'll just close all these things. Okay. So similarly, can you observe here, please? So however you mentioned attribute, auto create equal to true, generate equal to true, or auto create equal to false, generate equal to false, you can also mention those two meanings for attribute level also. For attribute level also you can mention. So that's why you can see whenever you are saying product code, auto create equal to true, generate equal to true, like that you are mentioning. So if you don't mention here, let's say you are not mentioning this auto create equal to true, generate equal to true, then it will get the behavior from the parent. If you mention here, then it will take this whatever you mention. So therefore these are optional. These are optional. So if you don't mention, it will get the behavior from the item type level. If you mention, so these will be considered. That's about the auto create equal to true, generate equal to true. Then remaining we will discuss tomorrow, and we'll also complete one example tomorrow. Tomorrow we have the session. That's all for today, and we can catch up tomorrow. If you have any questions, go ahead and ask.